All right, so we're still working on 1.1 and 1.2. We are now talking about domains. So we should finish up today. So, how many, does anybody remember how many restrictions I told you there were? 2 of them. So this is the first restriction. So from now on, when I tell you, tell me what the domain is, the very first thing that should come to your mind is what? No. Restrictions, okay? So normally when the teacher says, okay, let's talk about the domain, your brain goes X, okay? But now I want your brain to go restrictions. Does this function have any restrictions, okay? We have only talked about an implied restriction, all right? Which, when you learn these 2 restrictions down here, you'll look at this and go, that doesn't have any restrictions. But it does have an implied restriction, and we talked about that yesterday. Okay, so an X in the denominator, all right? So look, I'm fixing to make your notes so awesome, all right, that all you have to do is follow these and you'll know exactly what to do, because if you have an X in the denominator, you will have a restriction. Why will I have a restriction there? What cannot be in the denominator? 0. I can't make a 0 in the denominator. So any X that makes a 0 in the denominator will have to be excluded from my domain. Okay? So what to do? What to do if you have an X in the denominator? Well, first of all, you will set the denominator not equal to 0, because we can't have a 0 denominator, all right? Then you will solve for X, all right? And then you will exclude those numbers or number, all right? Might be 2, might be 1. Those number or numbers from the domain. All right? So, the next thing I want to do is I want to give you an example. Okay? An example. So, here's my function. F of x is equal to 3 over x plus 1. So, this is my function. F of x is equal to 3 over x plus 1. Let's talk about the domain, people. What are you thinking?
X is in domain. Restriction.
Very good. So we're thinking about restrictions. The only restrictions that you know right now is an X in the denominator. Does it have an X in the denominator? So what do I do?
Have the denominator not equal to 0.
Okay, so denominator, X plus 1, cannot be equal to 0. Now what do?
Solve for X.
Solve for X. So I subtract 1 from both sides, so X cannot be -1. Are you with me?
No, ma'am, because my White House broken.
Oh, sorry. All right, so now we're going to exclude those numbers from the domain. All right, so pay attention what's fixing to happen here. I'm going to do set and interval notation. That's what you're going to be required to do on your worksheet and the test. So let's do set notation first. Set notation, any X such that, okay? Now y'all listen to me. If you just put X cannot be equal to -1, then you're saying X can be anything in the world except -1. So, can X be 3i? No. It has to be what kind of a number? A real number. So we have to say that. So X is, now look, let me show you how to say is a real number. So you're going to draw a C, and you're going to put a little line in it. And that means is an element of. Now look, is that an E?
No.
It's not an E, people. Do not put an E there. Okay? It's a C. It's a curved C, and it has a little line in the middle. But it means X is an element of. Does anybody remember how to do the real numbers?
R.
It's an R, but it has to be what kind of an R?
Yeah.
Yeah, a double-barred R. So it has to be a double-barred R. X is an element of the reals, comma, X cannot be -1. Okay? So X can be any real number, but it can't be -1 because that makes a 0 in the denominator. All right? Now, interval notation. Interval notation, look, if you can't go from here to interval notation, remember what you always can do until you get like the gist of it again? You can always stick this on a number line, Okay? That means it can be any real number, except it can't be -1. So I got a little open circle there. So interval notation goes from, what is this? Negative infinity to,
Positive.
no, -1. Okay? Negative infinity, remember infinities are never included, so that's a parentheses. All the way to -1. I'm going to exclude -1 because I can't include. What? That's a parentheses. Union, no tail on that U. Don't put a tail on it. And then it goes from -1 to, there you go, -1 to positive infinity. That's a parentheses.
When would
sorry.
you include something?
If it was included in the answer. We're going to have some, so you'll see it.
Union.
Okay? So, here's what the interval notation says. It says, hey guys, it can be anything from negative infinity to positive infinity. But I'm excluding -1. All right, anybody got a question? Okay, so let's talk about the second restriction. The second restriction is if you have an x under the radical. Okay? Now, what kind of numbers cannot be under the radical?
0.
X.
The square root of 0 is 0. Negative. You can't take square roots of negative numbers and end up with real answers, guys. You're going to have imaginary solutions or complex. All right, so what to do?
X greater than or equal to 0.
Very good. What to do? Now, first of all, you're going to set whatever is under the radical. Whatever is under the radical, greater than or equal to 0. Then you'll solve for x.
Wait, what you said again?
Now, when you're solving an inequality, what's the only rule?
Divide, flip.
Yeah, if you multiply or divide by a negative number, you have to flip the sign. Do you think they're going to see if you know that rule?
Mm-hmm.
They are.
Wait, what?
All right. So the last thing, this is your domain. Okay? It is telling you what your domain is. What are we going to do now? What do you
So,
think we're going to do?
example.
Yeah, we're going to work an example. All right? So, example. All right, f of x is equal to the square root of x minus 3 plus 5. The square root of x minus 3 plus 5. So let's look at this function and let's talk about his domain. All right? What are you thinking?
There's a negative in there. Restrictions.
Restrictions. All right, does it have an x in the denominator? Does it have an x under the radical?
Yes.
Okay. Tell me what to do.
So equals, no.
Something greater than or equal to 0.
What do I set greater than or equal to 0?
Radical.
What's under the radical? Do I care about this 5?
No.
People, I don't care about anything outside the radical.
Wait, we don't care about the radical itself, do we?
No, I take what's under the radical, x minus 3, and I say you have to be greater than or equal to 0. Now I'm going to solve for x. Tell me what to do.
Add 3.
Add 3. So x is greater than or equal to 3. People, this is my domain. Okay? This is my domain. So in set notation, it would be any x such that. Now y'all listen to me. If I tell you that the x's have to be greater than or equal to 3, don't you know that they're real numbers?
Yes.
Aren't there real, the real numbers are only numbers that are greater than or equal to 3?
Inclusive.
So don't say x is an element of R. If you do that, I'm going to take a point away from you. You don't have to tell me that it's an element of R. If it's greater than or equal to 3, it has to be a real number. So all I do is say x is greater than or equal to 3.
And this is when you would put the bracket because it's
Okay.
equal to
So in interval notation, where does it start?
3.
Included or excluded?
Included.
So that's my bracket. All the way to what?
Positive
Positive infinity.
and exclusive.
Remember on interval notation, the smallest number is always on the left? That's the one thing that sometimes gets kids. All right, anybody got a question? Okay, so we're fixing to work 1, 2, 3, 4, 5, 6, 7 problems that are all about domains. All right? So by the time we work these 7 problems, you should be pretty good at this.
Is this the last one that we're on?
After that, we're going to do one word problem, but it's really fast. Okay? So, example 5. Find the domain. Find the domain. So here's the first one. All we're doing is finding the domain. My function is the set containing -3, 0. You want me to wait on you just a minute? Nope, you with me? Okay, -3, 0, -1, 4, 0, 2, 2, 2, and 4, -1.
Okay. I have just.
Okay? Now, I want to know what is the domain of this function. All right? So, should you all be able to do this problem?
Not yet. I will be able to do the second one.
What?
I don't even know where it's
You should. The domain, people.
I think I can do it. I think I'm doing
With
it.
all the X?
Yes.
Oh, my
Any
bad.
x such that x is equal to what?
3.
-3, -1, 0, 2, and 4. There's no way to write this in interval notation because it's not an interval, people. It's just these specific points, okay? So you can't really write that in interval notation.
There was a whole tennis. Repeat domains, you don't list them twice, right?
Okay, we're talking about functions, so functions will not have repeat domains. But if you were just talking about a relation and I said list his domain, you would not list it twice, okay? You would only put it in there once. This morning, one of the kids said, do we have to list them in order from least to greatest? Here's the general consensus. If there's just 1 or 2 of them, it really doesn't matter. But if there's quite a few, then it's proper to put them in least to greatest or some type of order because then it's easier for someone that's grading your paper. Do you see what I'm saying? I don't have to go and hunt for them all over the place. All right, everybody okay so far?
Well, there was a whole test where I mixed up domain and range last year.
Okay, domain and range. Who comes first in the alphabet, D or R?
D.
Who comes first in the alphabet, X or Y?
X. Okay.
There you go.
Thank you.
Okay, so that's an easy way to remember it. All right, so here's your next one. Your next one says G of X is equal to -3x squared plus 4x plus 5. All right?
Wait.
Let's talk about my domain. Now, as soon as I say let's talk about my domain, what's my brain thinking?
Restrictions.
Yeah, do I have any restrictions on this?
No.
Yeah.
Negative.
People, there are no restrictions. So, what's my domain?
Anything?
Negative infinity to positive infinity? Any real number. So, in set notation, any x such that, what?
Wait, we had to put
Any
the
X.
R.
X is an element of the reals. Okay? That says any real number. What about interval notation?
Negative infinity to positive.
Negative infinity to positive infinity. Remember, never include infinities, okay? All right, you okay? All right, here's C. C says h of x is equal to 1 over x plus 5. Okay? Let's talk about my domain. What are you thinking? What are you thinking?
Restrictions.
Restrictions. As soon as someone says, let's talk about the domain of this, we're thinking about restrictions. Does he have any restrictions?
Yes.
He has an x in the denominator. What are we supposed to do?
Set it equal.
Set it not equal to 0.
Okay, so x plus 5 is not equal to 0. Now, y'all listen to me. What if you set it equal to 0 and you solved for 5 and excluded it? Would you be okay? Yes, y'all. It's going to be okay. All right? So, I subtract 5 from both sides. X cannot be -5. So, you ought to be writing the domain in proper set notation. You should know how to do that.
Oh, yeah.
Is this the X element?
Yeah, and it's And it's like
Yes,
the X
you
not
cannot
equal to
just
five.
say X can't be -5, because then you're saying it can be anything else. It could be dog, elephant, 3i, 7i,
I think I did it right.
okay, but it's not. It is an element of the reals, but X cannot be -5. So any real number except -5. What does it look like in interval notation?
Negative infinity to 5.
-5.
Oh, wait, yeah,
-5 what?
Union.
Exclusive.
Oh.
And then
Okay? Union, no tail on that U, guys. Alright? -5 exclusive to positive infinity.
Yeah.
Alright, everybody okay? Okay? So, do you remember doing this last year?
Yeah.
Y'all learned this last year, and it was hard last year. Okay? Last year you like, oh, I don't like this. But this year you're like, well, that's not so bad. I don't know why I thought that was so difficult. Alright, so here's D. Still thinking the same thing, guys.
Oh, okay.
Volume equals 4/3 pi r cubed. Okay? Volume equals 4/3 pi r cubed. Alright, do I have any restrictions?
No. Oh, wait, implied restriction.
Oh!
Dang it.
These are implied restrictions because you obviously, what kind of numbers can you not have for R?
Negative.
Negatives. Okay? So, my domain is going to be any what? R such that R is what?
Greater than zero.
Yeah, I like greater than 0. Some kids will try to argue and say, well, I could do 0, just don't have a sphere. Whatever. I don't really care. Alright? So, I'm going to go from 0 to positive infinity.
So
Okay,
why
guys.
0?
What?
Wait, why 0?
It's not included. So
It's,
it
I
can't be
don't
zero.
include 0. Because if you include 0, are you going to have a sphere?
No.
Yeah, but you don't have a sphere
But
at
you would
0.
have a bracket.
You would have a bracket, okay? If you put an or equal to right here, then yours should be a bracket right there, okay? Could I use a 0?
No.
I mean, I guess, you wouldn't really have the volume of a sphere because you wouldn't have one, but, it wouldn't be anything improper, alright? Okay, so here's the next one. Now, after we do this one, we're gonna do some that you're gonna go, uh-oh, these might be a problem. Because we haven't done any hard ones, so we need some hard ones.
I was hoping it would stay like
I was
that.
hoping it wasn't the but I guess not. That's it. Are we doing this one ourselves?
Uh-huh, I'll let you do it.
What you trying to do?
Notice that it is greater than or equal to 0 because you can take the square root of 0, okay? The square root of 0 is 0, and that's okay. You can't do negative numbers. Ding, 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 ding. That's where all the bells and whistles ought to go off.
I think I did
X
right.
is what?
Less than.
Less than or equal to. Multiply or divide by negative, and you must flip the sign. So this becomes my domain, okay?
Wait, if you divide by negative, then you flip the sign?
Yes, if you multiply or divide by a negative number, you have to flip the sign, okay? So, y'all know why that's happening? Y'all know why that's true? Look, do you agree with this? Do you agree that 4 is greater than 1? Everybody agree that's true?
And
Okay, so let's multiply each side by negative 1. So what's negative 1 times 4?
-4.
What's negative 1 times negative 1?
Negative.
Negative 1 times 1.
Oh, then it switches.
Now what happens?
You have to flip it.
Okay?
So are you
So-
just making it true?
Yes. In order to make it true, because that's what we want. We don't really care about false stuff.
Yeah.
Alright? So here we go. My domain is any x such that, do I have to put x as an
No.
element of R?
Yes.
No. People, when it's an inequality, do not write that. I'll take a point away, but I'm not counting it wrong, but I'm not like, you don't need that. So x is less than or equal to 4/3.
Wait, so we don't need that if it's inequality?
If it's an inequality, what kind of numbers are less than or equal to 4/3?
All of them.
Real numbers. Real numbers. So you don't have to tell me that it's real. Okay? They're the only kind of numbers that are less than or equal to 4/3. All right. Interval notation goes from negative infinity, which is not included, all the way to 4/3 with a bracket. Any questions? Everybody good? All right. So, here we go.
Wait, so inequality, that's the, that's what's greater than or less than signs? When it's an inequality,
A lot of people,
right?
they're just doing it.
I'm sorry, what?
When it's an inequality, which is the negative, or, the greater than or less than sign?
Mm-hmm. Yeah.
So we never put the x or whatever variable element?
No, Eleanor, nope, you don't. Okay, so this is example 6. Still the same directions, find the domain. All right, but these,
Are these only, they're only two?
these are gonna be scary. All right, they're gonna be scary, all
Is
right?
there only two of these?
Yeah, only 2 of these.
Alright.
So I'm gonna show you how to do one of them. I should be y'all listen to me. I don't expect you to just right now know how to do everything that you learned in Algebra 2. But I do expect that I can work one problem right here on this paper, and then you go, oh yeah, I remember how to do that. And I jogged your memory enough that you can take off with it and work the problem. Okay? So, let me show you what the problem looks like.
I tried to draw that, but mine looks like the sun and sunglasses.
Look at
I
mine.
don't know.
Alright, so here we go. F of x is equal to the square root of 9 minus x squared. Okay, so we're still doing the same thing, guys. You're still going. I'm going to talk about the domain. So, do I have any restrictions?
Yes.
Yes. So, what do I do?
I don't know.
Take what's underneath the radical. We're not changing the rules of the game, people. Okay, the rules of the game don't change.
But
Those
you're
are cheaters
squared,
that do
so-
that.
No, but
All right, so you take what's
okay.
under the radical, 9 minus x squared, and you say you must be greater than or equal to 0. Okay, so here's what's different. This is a quadratic. This is a quadratic inequality. This is chapter 4, section, it's either 7 or 8. Okay, so, you know, you were probably traumatized when you learned it. Let's see if you remembered it. All right, so the first thing that you have to find are what are called the critical values. Those are the solutions. If this were an equation, they would be the solutions to this equation. So how do I solve a quadratic? The easiest way is to factor it. Okay, the easiest way is just to factor it. So what does 9 minus x squared factor into?
X plus 3 and x minus 3.
Flip it.
X minus, oh, not a 3, 3
Yeah.
plus x.
3 plus x
3
and 3 minus x. Just because this was flipped, these are flipped too. Okay? Now look, if x plus 3 is the factor, what's the root?
Negative 3.
Negative 3. If x minus 3 is the factor, what's the root? What's the difference between factors and roots? What do? They change the signs. That's all they do. And here's what happens, guys. It's what you would get if you set this equal to 0. So 3 plus x equals 0. I'm going to subtract 3 from both sides, and x equals negative 3. That's where we got this number. Okay? If you set this guy, he looks a little weird, but if you said 3 minus x equals 0, I would add the x to both sides.
I'll look down for 2 seconds, Ms. Davis.
And 3 is equal to x. So those are I just showed you where these things came from. Okay? Now we call these critical values. But y'all, all they are their zeros. They're answers, they're solutions, they're x-intercepts. That's what I'm fixing to do. So here's the way I taught it. I taught it for you to cheat and get the answer with a picture. Okay? So watch. This is my x-axis. Do you agree that this intersects the x-axis at -3 and +3? Are y'all with me?
Yes.
Okay.
Wait, why did you get the I remember it, but I don't remember why.
If you set this equal to 0 and you solve for x, what would x be?
-3.
Okay, if you set this equal to 0 and you solve for x, x will be +3. Okay, so I put my critical values, those are just those solutions, and I put them on my x-axis. Now y'all listen, this is an x-axis. This is the same thing as a 0. Okay? Above it is greater than, and below it is less than. Does that make sense to you? Okay, so the next thing I want is when I graph this, what's it going to make? A parabola. How's it going to open? Down, because it has a -x squared. So I draw my little parabola opening down.
I think that isn't much.
Okay? Now, here's the deal, guys. The hump or the tails? The hump or the tails. That's all I want to know. So, what you do is you go back and you read this statement. This statement says, hey man, I want the part of the parabola that is greater than 0. Would that be above the line or below the line?
Above.
That's above. So that is the hump. Now, where are the x values? Because that's really all I'm looking at. Where are the x values that give you the hump? Are they in between the numbers or on the outsides?
In between.
In between. Remember, the hump is always in between and the tails are on the outside.
Always?
Uh-huh. So, my solution would be from -3, inclusive, because it's greater than or equal to +3, inclusive. Okay? So, let's write my domain. That is my domain, guys. Alright? My domain is any x such that, here's the way I'm going to do it. Alright? Do you agree it's all the x's between these two numbers? So I'm going to put my x in the middle. You always point your arrows in the
Greater
same
than
direction.
-3.
I always point mine to the left, and that way it makes sense for my small number to be on the left and my large number to be on the right. So I make mine this way. And that way my little number goes here, and my bigger number goes here. X is greater than or equal to -3 and less than or equal to +3. Interval notation, this is interval notation. If you write it this way, your interval notation is looking at you from -3 to +3. Okay, everybody all right? Do y'all remember maybe a little bit of that?
Yeah.
Okay, so here's the next one. G of x is equal to 2 times the square root of x squared plus 5x plus 6 minus 7. Tell me what the domain is.
Okay, hold on, we're gonna have to do this one.
Oh, I remember how to do this. I think.
You do?
Here's your choices, okay, Eli? All you want to do is find the critical values. How do you find the critical values? People, you factor and solve. Factor and solve. If you can't factor, you would have to use the quadratic formula. Okay? There was a negative boy who was kind of iffy. He went to a radical party where there was square dancing. He missed out on 4 awesome chicks. It was all over at 2 a.m. Okay? But this one factors nicely. So find your critical values, and then which way does your parabola open? And what do I want? The humps or the tails? Hump or the tails?
Tail.
Well, that's sad.
Wait, when we do when we factor it, we can just set it equal to 0, right, to make it look easier?
Yeah. So I'm going to start up here. I'm not going to say anything. Okay, I'm just going to start working mine.
So you don't.
I have my zeros.
The fact factors of 6 that add to be 5?
Oh,
2 and 3.
no, I wrote
1
down
and
3.
6 subtract to be 5.
That's
Don't
what I
add
did.
to be 5.
I
Okay.
knew it was 3 at the end, that's why I couldn't.
No, because this is a plus sign
It'll
right
be a
here.
negative six.
He says find me the ones that add to be 5.
Oh, dog.
Make sure that you put your critical values in the right order on the number line, people. Okay? If you put them in the wrong order, it'll mess up. You'll be messed up.
Ms. Davis, you know what I did?
But,
I put, x squared plus 5x plus 3. That's
no,
why I
that
forgot
wouldn't
how to
factor.
factor.
It wouldn't factor. Okay, you're gonna, if, I gotta find out which way my parabola opens. You look at the x squared, the quadratic term. If it's positive, it opens up. If it's negative, it opens down. So this guy should be opening up.
That's what I thought.
Okay? Now, because we're working with inequalities, these are always going to be greater than or equal to 0. So you always want to pick what's above the line. So would that be the hump or the tails?
Tail.
Yeah, that's the tails. Where do you get the solutions for the tails?
Outside.
Yeah, they come from this outside part. Okay? It does include this little thing right, that point though, because it is greater than or equal to. So, my domain, any x such that. Y'all listen to me, this is an or statement. You can, for a set, you can use the word or you may use the union symbol. For interval notation, you have to use the u. So, just use the u all the time, all right? So what does this inequality say? X is what?
Negative infinity.
No, stop. Inequality. X is less than or equal to -3. Now, don't you think it makes sense to put this one first?
Yeah.
People, don't put this one first. I'm gonna mark it wrong. That's just crazy. All right, you read from left to right. So then union or x is greater than or equal to -2.
So they don't have to go the same way for this?
No, because it's not an and statement. If it were an and statement, that means one that's together.
Yeah,
Then that means they have to go the same way. If you have them pointing different ways, it's wrong.
like if it was the hump they have to.
Yes, if it's the hump, it's going to be an and statement, and they would be. Okay, so I'm gonna go interval notation, negative infinity, never included, to -3, included, bracket, union, -2 included, to positive infinity. Okay, so do y'all remember those from last year?
Yes.
All right, were they easier this year?
Yeah.
Okay, so anytime you learn something the second time, that's why I know that some people go, she goes way too fast. But even if I can just introduce you to some stuff, when you see it the next time, you'll be like, oh yeah, we did that. I never got it, but oh my gosh, this teacher's so amazing, now I get it. I wish Miss Davis had done that. All right, that's what happens a lot of times. I'm like, oh, okay. All right, so here we go, example 8, last one. A baseball is hit. I think this might be a run-on sentence, okay, but I'm not sure. A baseball is hit, Travis, you taking notes? At a point 3 feet above the ground.
Parabola.
At a velocity of 100 feet per second.
You got my brain thinking so fast, I wrote at backwards, I put TA.
And at an angle of 45 degrees. The path,
Yes, there should have been a period there.
the path it follows is given by colon. F of x is equal to -0.0032 x squared plus x plus 3. X is my horizontal distance, and Y is my height. All right,
No, don't make it.
here's my question. Are y'all ready?
Not yet.
No.
Almost. I'm writing that assumption down. The equation B.
Okay, my question, will the baseball, it's just info, like what are you gonna do with that? Okay, thank you. Will the baseball clear a 10-foot fence located 300 feet from home plate?
Yes, yes, it
We're not guessing.
Especially
Okay.
if I
Okay.
had multiple choice.
Yeah, we're not guessing.
It's a 50-50 shot.
All right, so tell me what to do.
Maybe. You heard no maybe.
Find the domain.
No.
Wait, just makes X 300.
Do what?
Just plug it in. Make X 300. Plug it in.
Exactly, people, all you gotta do is plug that, that's 300 feet, that's my horizontal distance.
Oh.
I'm gonna plug it in for X, and what am I gonna see?
This is the height, which is that?
If, that's exactly right, at 300 feet, what is the height? Okay, if it's more than 10 feet, the answer is yes, and if it's less than 10 feet, the answer is oh, so sad.
I need a calculator.
So,
Not working
f of
that
X is
well,
equal
though.
to, I'll do it for
I'm
you.
not doing that.
Negative point 0032 times 300 squared plus 300 plus 3. Okay, so I'll do it in my little handy dandy calculator. So negative point 0032
No.
times 3,
I don't
what?
think it's
300 squared plus 300 plus 3.
It's not making it. 9.7.
15!
Oh.
Boom!
Well, we got
It would be perfect.
So therefore, you see those 3 dots like that? Okay, that's what that means. It's that notation, that means therefore. Therefore, my answer is what?
Yes.
Yes.
Yes. Yes, yes, yes.
Wait, let me write that little dot there.
Okay, therefore my answer is yes. So, let me show you something else, all right? I just want to show you this really quick, and then I'll let you get to work. All right, so I went to y equals, all right, and I plugged my equation in right there, okay? So, I'm going to go to the windows, and I want you to tell me what I said set my windows at, okay? So, x is my horizontal distance. So, what's the smallest?
0.
0.
Can't go there.
Travis was the longest. Do you have any earthly idea what we're talking about?
300?
300. Well, that would just be to the fence. Could it go over the fence? I mean, what's he going to do? Get to 300 and go boom.
350.
350, okay? So I'll be okay with 350. I'm gonna go by 35 for some insane reason. All right, what about my Y? That's my height. 0 is my min. What do you think the highest that it might be?
50. 50.
50? I'm gonna say
70.
100. I don't think it'll be 100, but
That would be a.
Oh, because it's a parabola. It's gonna
so
go high.
yeah, y'all, it's a parabola. It's not gonna be a line drive, okay? I don't think a line drive's gonna go 300
Home
feet.
run line
All
drive.
right.
You just beamed it 100
So
feet.
here we go. Graph. So
Yeah, I can
it
see
got
the
pretty
baseball.
close. You can see it got pretty close to 100. All right. So I'm wanting to know what the value is at 300. So watch what I can do. I'm going to go second and calculate. And the very first thing that comes up is a value. So he can calculate values for me. So I'll choose that one and I'll say, hey, tell me what y is when x is 300.
15.
He says 15. And I'm like, oh yeah, I did, made it over the fence. Let me show you another thing I could
Will
do.
we have a calculator?
I could go to y equals, and I could go down in here, and I could put the fence in. The fence is 10 feet high.
Oh, yeah, and it would be just.
Is this a
straight line.
visual
Okay,
of it?
right.
Yes, it is. You're wanting to know what is this point right here where it intersects. Okay? So I go second and calculate. Number 5 is the intersection. First curve, Yes. Second curve, yes. I don't wanna guess, but y'all look, if you wanted to pick this point over here, you need to be closest to that point. I don't have to be right on top of it, but he's gonna pick the closest one, cause he's lazy, all right? So, there it is. There's my 305. He, at 305 feet out, he was 10 feet high. Did he go over the fence? Cause it was at 300 feet. Good job. All right, everybody okay?
Yeah.
So I'm gonna pass out your worksheets, your test. You will have tomorrow in class to work on your worksheets because 21 of y'all or something are gonna be gone tomorrow. So, yes.
Ms. Davis, I love how you were sticking with Friday.